And that's not doing anything, so I'm going to ignore it. And coming back to, all right, we are live, which is good. And I'm going to click this over here because that hasn't worked on the Instagram because it never does. But now, can I say hello, Dr. Sarah McKay, author, speaker, and I can see behind you, you've got your book there, which is wonderful, which I have just sped read in the last couple of days, the Woman's Brain book. And this is your fourth
Part
book.
two.
Part
well,
two.
This is so the original version of the Women's Brain book was in I wrote it in sort of 2016, and then this is the update because so much has happened.
Yes, so much has happened.
So much has happened, and I might have to keep updating it every 5 to 10 years going forwards because, as I say, women's brain health, or women's health really, is no longer a niche topic.
No.
And it kind of was. And now it's not.
It kind of was, even though, I mean, we have an incredible, as you know, both you and I know, we have an incredibly long way to go in closing things in terms of gender data, gender health gaps, and all of those sorts of things. But at least now they are being discussed. And as long as Trump doesn't decide to cut down any more, you know, women's health initiatives or things like that, then perhaps we might actually start getting something.
I think we know that there's a gap. I think before it was almost we were oblivious. I think certainly when I was doing research, I didn't think about biological sex as a variable. And it wasn't because I had an agenda to exclude females or women or whatever. It was it just didn't occur to me to consider sex as a variable. And now now it's kind of in the forefront of everyone's minds. That will also be driving things forward. We can't, unsee that data gap now, and there's so many people working to fill it. So that's, I think, it's good news.
It is
funding is, funding is
an entirely another issue, which is why I set up the charity. I don't know whether you know, actually, because it's been quite a long time since we've spoken, but I have set up a charity called the Menopause Research and Education Fund, which is aimed specifically at trying to get better funding for these kinds of things.
That's what we need and want. We like that.
We do. Yep. It's hard to get money out of people, but c'est la vie. Very hard to get money out of people. Anyway, there you go. Now, let us start, because you threw a bit of a cat into my pigeons the other day, because I thought, the main thing I normally talk about is menopause and menopausal brains. And you sort of said back a bit saying, there's actually quite a lot of stuff in the rest of the book. And so when I was sort of reading through it, I thought, oh, Christ, she's absolutely right. I am going to have to start way back in the womb.
Just start at the very beginning. Yeah,
you can't really explain what happens later on unless you really sort of understand what happened earlier on. So, but before we get to those sorts of changes, I just want to knock a few myths on the head, because I think that
I like a bit of a myth bust.
The myths in childhood probably also play into the myths that we continue to hear later on in life. So let's start with some of the more common ones. Boys are smarter than girls.
Well, I mean, that's a myth. I suppose the thought behind that myth would be that there are biological sex differences between boys' brains and girls' brains, which there are, and we can talk a little bit more about how much of a difference is there. But in some way, the male brain is superior and it makes it smarter. But there's however we would define smart could be defined in a million different ways depending on who you are and where you live in the world. But we could look at a whole lot of different types of cognitive testing. And if we tested 1,000 boys and 1,000 girls, often we would see no difference in those standard deviations, because we've got to look at big populations of people. But sometimes on some types of tests, we might see slight variations in those distribution curves. And when we see differences, often they appear after puberty, which is interesting because that might lend us to think, well, maybe there's something to do with sex hormones. And typically the tests that boys or males do better in after puberty are ones where we know testosterone might play a little bit of a role, but it is as likely that a test score would be influenced by biology as it would be by socialization. So we know that girls often perform on average better in other tests, say, of verbal memory and learning. So remembering lists of words or naming, I don't know, animals starting with the letter C. But that's when we look at a distribution curve. When we look at individuals, everyone's got pretty much an equal potential to be able to perform in a different way, no matter whether their brain is male or their brain is female.
All right. Then when it comes to maths, and this is an interesting one, boys are better at maths and science.
Well, they're not. I'm a neuroscientist. I think I'm doing all right. So what we do, as I said, what we do see in some types of different cognitive tests, we see a little bit of a sex difference. But again, it's more looking at a standard deviation curve, and we might see people at like kind of either end of that standard deviation curve. What I think is more interesting is if we do see differences, where do they emerge? And does that mean that there is a difference in a brain that means it functions in a better way and can do maths, or is there something else going on? And there's some really interesting research that's been done looking at if we do see differences in scores, where does it come from? And this is a study. Are you familiar with the study that came out from France earlier this year? It was published in the journal Nature, which we know is, top flight journal. I have to look it up. But basically what they did was they went in and looked what happens when little boys and little girls start school, and they come into school with comparable maths ability, but a gender gap starts to appear during that first year of school between boys and girls, kind of within sort of the first 4 or 5 months of school. And it doesn't matter what age the children are, because you could have children with birthdays a few days apart, but they're in completely different years of schooling, and something happens when the kids start school where they have the similar ability, but then we start to see the test scores diverge. So the boys are scoring better, but that doesn't mean they have a greater ability. There must be something going on in terms of how children are learning or performing or being taught or experiencing learning maths in the classroom. So we are seeing slight differences diverge in test scores, but that doesn't mean the ability to do maths is different. There's a whole lot of other things going on. You've got like sociology as well as biology there. So it's a really complex and interesting problem, I think. And also we see
those later on, or because I guess that is why.
I mean, the gap is pretty small, but what we tend to think it is, and so some researchers, and I talk about this in the book, is that researchers have gone in and looked at girls' perceptions of their ability as a mathematician or as a future scientist or as a smart kid. And all kids start school, whether they're boys or girls, saying, yeah, I'm smart, I can do maths, I can be a scientist one day, I can grow up to be a doctor, I can be whatever I want to be. But within a year or two of schooling, boys will persist with that. I'm the man, I can do anything, like what all boys and men are globally. They are confident in themselves. But we do start to see some girls within that first year or two of schooling going, oh, well, who's the smart people? The boys. Who's going to learn the complex maths game? Oh, the boys, not me. They start to perceive themselves as less able when it comes to the maths abilities. But then we see the girls thriving in other types of like sitting down, being quiet and being nice and behaving. So it's hard here to start to unpack what's based on the brain and what's based on biology and what's based on sociology and learning.
Yeah, interesting. I remember too, actually, this is 20 years ago, but just thinking back when my son was in grade 2 or grade 3 and, they had the after school activities, the boys all went to Kumon, the maths class, teaching how to do maths. Hardly any girls went. And it was interesting. You kind of thought, why are the boys all being sent off this money?
Yeah. It's really interesting, and I've seen that. Like my boys are at a co-ed school. My oldest is in his final year of high school now. He was actually at school on the holidays today doing maths. He's a very talented mathematician, but I wonder if I say that because he is a boy. But it's interesting because if you look in the first sort of 3 or 4 years, go to the prize giving every year. I love this kind of thing. Go to the prize giving, look to see who gets first in class. Sort of, the 13, 14, 15, 16, I would say 70 to 80% of first in classes are girls across the subjects. And then once you hit that final year in high school, it flips. And then the boys start getting all of the first-in-class prizes and get the ducks, etc., and get all the higher HSC marks. It's so interesting, and I'm not sure how much of that is biology, how much of that is socialized, how much of that is learned. And I think it's a complex combination of both. And talking to my son about it, he said, oh, well, the girls are too busy fighting with each other to study, which is hilarious. But I think what the boys and testosterone partly drives this, but so does socialization, are very happy to compete, and status is really important, and hierarchy is really important. And they're quite happy to have status and hierarchy and to compete against each other, which kind of promotes, doing better in class, whereas the girls are perhaps a little less likely to, because you kind of socialize not to want to compete. So the boys have got that hubris, that belief in themselves, plus the competition. And then the girls' lives are becoming more socially complex. They're less likely to compete, and perhaps sitting quietly, being nice and diligent, and isn't as useful when it really comes to kind of the crunch. That's just my random observation of my kids' high school class. So I think it's really important whenever we're talking about sex differences is to think about there are hundreds of different measures we could make of a brain, from shape and size to volume to functional connectivity to hormones to reactions to disease risk to cognitive test scores. And whenever we see differences in populations, it's typically there's lots of overlap and there's usually tiny differences. It's usually a combination of biology but also biography. So how we've learned to behave, but it's also there is biology underlying some of that.
Excellent. The interesting thing about the girls fighting about each other plays into my next question, which is basically once we hit puberty, we become emotional, we're irrational,
Gosh,
and we're hysterical. Is that true? And how does that impact on us as we grow?
Well, I always want to push back on this idea about women being emotional, irrational, and hysterical, because every single time anyone toots at me for driving too slow or having a split second too slow reaction to the light going green, or I've changed lanes in some undesirable way, or I don't know, my car's a red Tesla, it's usually an emotional, irrational man who doesn't seem to be able to control his sort of big boy feelings a lot of the time. So I'm not entirely convinced that the claim that women are irrational and emotional more so than men plays out. I mean, we could take a global perspective of what goes on in the world and make some statements there as well. So I think
we don't often be proud of each other outside of a pub. Let's put it that way.
Yeah, I don't necessarily think women are the ones that are overly emotional. So we can kind of joke about it like that. We can look at how we talk from the moment a girl hits puberty. And I always say, if you've got a female brain and as soon as you start adding some sex hormones in, whether that be a menstrual cycle, pregnancy, menopause, we talk about dysfunction and decline and instability. And the combination of these things is always something negative and bad. And we start talking about hormones being the culprit and the driver of this from puberty. So, we can unpack it that way. We can also look very carefully at the careful data that has been gathered and analysed. We can compare sex differences in terms of emotionality, and very careful studies that have been done looking at how emotion varies during the day in a positive and a negative and a neutral way, comparing males and females, and the references are all in the book and we can share all of these afterwards, has found that males and females' emotions don't differ or vary more or less than each other on a day-to-day basis, or really across the course of the month. Do we get more emotional when we go through puberty? That's a really interesting question, because there are some kids when they're entering puberty do become more vulnerable to develop things like anxiety and depression. And is it solely to do, again, with the combination of hormones in a brain? There's some very interesting longitudinal studies of child development, and I really like to talk about these because I think they highlight this idea that if you've got a girl going through puberty much earlier than her friendship group, so she gets breasts, say, at age 9 and her period at 10. I mean, that's early but normal. She's not 5. It's just she's on the early, early sort of side of the normal distribution curve. She's much more vulnerable to develop depression and anxiety compared to a girl who goes through puberty the same age as her friendship group or a bit later than her friendship group. Whereas if you've got a boy who goes through puberty earlier than his friendship group, well, boys get kind of tall, big and hairy, and they almost become kind of the alpha in their group. And they get more respect from the boys around them, but also the adults around them expect quite a lot of them too. And they're often more protected against depression and anxiety than a boy who goes through the same age as the boys who go through much later than their friendship group. So you've got kids and brains experiencing sex hormones for the first time, but the outcome in terms of emotional stability and then perhaps even mental health depends on the social situation and context in which that's happening. Because especially an early pubertal girl is like looking at herself and looking at everyone else. People are looking and treating her differently. She may not be emotionally ready for the changes that are taking place, and she sees herself as a little bit different. And that vulnerability can then carry through and make her more vulnerable and sensitive to other shifts and reproductive transitions later in her life. It might not necessarily be the hormones per se, but it's providing an emotional blueprint for later on.
Yes, interesting. The narrative about hormones, because you touched on people, looking at cycles and sorry, somebody's annoying. Looking at the cycles and how things change, and we seem to have at the moment a bit of an industry developing around, you'll perform better at this part of your cycle.
Yeah.
All your sporting results will be better at that part of your cycle. If you're in a period, your entire life falls apart or whatever. Is there any in any of this?
Yeah, it's interesting because there's different things to look at and consider here. So we've got emotion, and does that vary across the cycle? We talk about that in a bit because the answer to that is more convoluted. In terms of cognition, and so we would separate them out, and cognition would be things like executive function, like planning or judgment or reasoning or problem solving, or we could do different types of test scores on things like memory or reaction speed or remembering a list of numbers, or what was various types of tests of cognition that we can do across the menstrual cycle. And we've actually been studying these for a really long time. Well, not me personally, but people were looking at cognitive test scores in different days of the menstrual cycle back in the 50s and 60s. So it's one area of women's brain health, which is actually not, neglected. And back then they were finding day of the month didn't really matter in terms of cognitive test score. And those tests have been repeated over the years, and most recently repeated and done with daily blood draws, so we know exactly which day of the cycle a woman's on. And there's absolutely no variation in cognitive test score at any day of the month. It doesn't matter whether you're ovulating, whether you're on your period, whether you're in the luteal phase, which I think is super interesting and quite good to know, because it doesn't really matter what day of the month it is, your cognition's pretty level and stable. So ovarian hormone fluctuations across the course of the month aren't sort of changing anything there. In terms of sporting performance, interestingly, a study was done in the last year or two, and again, we'll provide the references afterwards because off the top of my head, I don't want to give the wrong names or dates, looking at when athletes, and they did this in partnership with FIFA, I believe, looking at things like reaction time and asking women when they believed they performed best or worst. And lots of girls and women said they thought they performed worse when they were on their period. And actually that wasn't when they were performing better or worse. It was exactly sort of similar. And any sort of differences they were seeing were really microsecond timing differences in reaction times, but not necessarily when the girls or women predicted that those differences emerged. So your perception wasn't necessarily matching up with the exact scores, and it was microsecond differences. And maybe that's the difference between a gold or a silver medal if you're an Olympian, right? But for you or me, it's not that we probably get periods that often anymore. Well, so me neither. So that's probably not going to make that much of a difference to the vast majority of people's day-to-day living. Emotion and emotional reactions and I suppose stability in how we feel and react and respond. There's so many different ways we can describe what an emotion is or how emotional you are. And this, and I suppose the easiest way to talk about it is to think about, well, what's PMS or premenstrual syndrome or PMT? Not this more severe form of PMDD, but just like basic bog standard PMS that lots of women say that they have. I mean, even the rates or the numbers of women that will put their hands up saying I have that varies widely in different countries in the world, which I think is really interesting.
In your book, you said that basically by strict definitions of it, it's somewhere between 1.7 and 7.7% of women. So
that's for PMD. That's for PMDD, which is premenstrual dysmorphic disorder. That's very serious type. But PMS, that's like self-reported, I have PMS, varies between sort of 10 or 12% in France and up to 90% in Iran, right? So it can't be no one or everyone. It can't be biological. There must be like a social reporting kind of thing in there. And there's lots of different kind of feminist theories about you're more likely to report that you have PMS if you're experiencing gender inequality because you suppress your emotions except for one time in the month when you're allowed to tell everyone how you feel. But careful studies, again, doing blood tests, doing very careful daily measures of emotions and giving women equally, you can choose that there's as many positive and neutral and negative emotions to choose from in a scale, doesn't find very much variation for most women across the course of the month. There is a subgroup of women who do show some kind of variation, and it's kind of somewhere between 1 to 7%, maybe around 5% of women show a clear variation, and typically it's a lowering of mood in the luteal phase, like those premenstrual days when progesterone's kind of coming down. But that's not universal, and I think it's really important that we start to, when we're talking about any aspect of brains and cognition and emotion and hormones, start to be much more careful and thoughtful about talking about individual differences and variations and going, if we've got a group of women here who do have this experience and a group of women over here that don't, I mean, it's really interesting to know who does or who doesn't. Why are some women more hormone sensitive? Why are some women sensitive to the offboarding or the onboarding of hormones? Are these women who are, some of the more recent conversations, even within the last couple of days, publications have come out. It's like, are these women who have also been diagnosed with ADHD? Are these the girls who went through puberty really, really early and they've developed some kind of vulnerability or sensitivity to hormones, or they kind of react more emotionally or sensitively to shifts and changes of hormones? Not everyone is going to be the same and react and respond in the same way. And I think as soon as we start assuming that everyone's going to have PMS, lots of women will start seeking out and experiencing negative emotional states when they might not otherwise necessarily experience them. Some studies have found actually emotions are far more likely to vary based on how socially supported you feel or your overall well-being or how stressed you are, much more so than day of the month. But I think we do ourselves a disservice. We just bang on about it if it's like only the hormones are the drivers, because I don't think brains only consider hormone status when they're making a moment-by-moment decision about how to think, feel, or behave next. Brains aren't just listening to hormones.
Yeah, interesting. But now, obviously, though, when the brain is developing, from womb, puberty, pregnancy, and we'll get to menopause afterwards, hormones do sort of play some sort of role in that development. What's going on?
Yeah.
Quickly for what's happening in the womb and the puberty.
And utero development is really cool because you've got XX and XY, so you've got two fetuses. You've got an XX female and an XY male fetus. The Y chromosome in the male fetus has this kind of gene called the SRY gene. It switches on and it causes the development of the reproductive tract develop down the male path, and the testes and a penis form, and the female just kind of carries on as kind of like the default or by destiny or whatever language you want to define, and develops ovaries and female reproductive tract. No, the ovaries don't turn on and start producing estrogen, but the testes in the male do turn on and start producing testosterone. But then this is kind of wild. The testosterone starts to masculinize that little baby's body, but it also masculinizes the brain. But the way that testosterone masculinizes the male brain in utero is because it gets converted into estradiol in the brain by a particular enzyme called aromatase. And it's the estradiol in the male fetus brain that masculinizes that brain. It's not the testosterone, it's the testosterone converted into estrogen, such that when that brain hits puberty, it's almost like there's kind of been this pattern set in place, and then that kind of gets activated by puberty. So then it can sort of start responding to testosterone and go through that kind of whole reproductive kind of development phase that we see at puberty, whereas the female brain just kind of carries on as is. And we know estrogen is so important to masculinize the male brain in utero that studies have been done, not in humans, but in lab animals, whereby you've got a female, an XX fetus, and you expose that fetus to estrogen, and that brain becomes masculinized such that that rat or that mouse, when it hits little mouse or rat puberty, it starts to behave like a male. So it will like mount other females and try and hump them instead of being receptive to being humped, even though it's a female rodent. So it's kind of like, I think Mother Nature played a good joke there on the little male brains to make it estradiol that masculinizes the male brain. And then that's kind of all within the first few weeks of in utero life, and then the brain's just kind of, the baby's just kind of developed. But what is so super interesting is that if you think about, you've got an egg and a sperm, you've got a male or a female fertilized blastocyst rolls down, embeds in the uterus. The placenta that develops is either a biological male placenta or a biological female placenta, which is kind of wild. No one ever thinks about the placenta having a biological sex, but it does. And it may be that the male placenta is slightly more vulnerable than the female placenta, whereby if you've had 1,000 pregnant women and they went through some like terrible, natural disaster, which was incredibly stressful, the male unborn babies would be more vulnerable to go on to develop neurodevelopmental disorders than the female unborn babies. And we think that the male placenta is probably slightly less resilient than the female placenta, but we don't really know why.
Interesting. There you go.
The
next spot where hormones, I guess, come into play massively is when we hit puberty. What happens to the brain then?
So ovaries turn on, start cycling estrogen, progesterone. We've got the monthly cycle established. Regular ovulation can kind of take a while, although some girls kind of settle into their cycle straight away. Males, testosterone, and I've gone, teenage boys in the house, so I know what male puberty is. Male puberty is wild as well. Like, watching boys become men is like, testosterone is very powerful. It has been very eye-opening. I've got like these 6'4" massive boys, men in my house. It's crazy. But what we see in terms of, we see these sex hormones, whether it be the male or whether it be the female sex hormones, make their way up into the brain, and sex hormones make their way, and they can latch onto receptors all through the body and all through the brain. And receptors are kind of like, like a molecule, a lock and a key, and then that switches on a cascade of responses within a cell, within a neuron, within the brain. And what we see is that puberty kind of catapults that brain forwards into this phase of adolescent brain development. And we see, whether it be a male or a female brain, they both follow a very similar trajectory of development, whereby we see a refinement in a lot of the connections and a lot of the networks that have developed during childhood, and they really kind of the brain becomes very plastic and very responsive to experience again in adolescence, much like the language centers of babies' brains are very plastic and responsive when they're learning to talk, for example. So brains go through puberty too, and male and female brains follow a similar trajectory. It's just like the hormones kind of give them that kick start. And so the experiences that pubertal and teenage brains have are vitally important to wiring up, this brain as it's going from adolescence into adulthood. And we see particular structures and networks refine and become more segregated and efficient and better at their jobs, in particular around social cognition. So thinking about what other people think and feel. And that's why other people are so important to teenagers, They fundamentally require very rich social experiences to guide that brain development. You need experience to guide that brain development. And we also see a lot of the higher order executive functions, things like emotional regulation, planning, judgment, ability to do calculus and chemistry and physics and all those crazy things that teenagers seem to be reasonably adept at doing compared to some of us. I used to be great at that. Now I don't even know how to differentiate an equation. And we also see
way ahead of me.
this real switch from, the family nest and mum and dad, and this switch from that through to, they're becoming an adult out in the world. And that requires a lot of courage and a lot of bravery, because you need to be quite brave to leave the nest. And so we tend to dismiss, we've got all these awful words we use for teenage brains. We thought they're half developed, half renovated, whatever. I hate that language so much. It's so dismissive and derogatory. Whereas like teenage brains are sensation seeking because they need to be brave and they need to be courageous. Sometimes that can look like bravado, but they need to go out and seek and do things. They need to go and drink, and they need to go and, roll around the beach and the sand dunes. They need to, do all of the crazy nighttime things that young people do, all of that sort of crazy sensation seeking that to us looks like wild and crazy and dangerous. And if you've got teenagers, you're like, oh my God, what are you doing? But it's just part of that process of becoming an adult. And all young mammals do that because the brains need the sensations in order to wire up. We just kind of hope we've provided a framework around the young people that they're not going to jump off a cliff, but they'll, have some new and interesting and exciting experiences.
Yeah, it's interesting because do we need to reframe this in a way than the way we think about it instead of being half-baked and risk-taking and dangerous, and look at it as actually sort of like, well, this could actually be a positive thing.
Well, it is. It's sensation seeking, and we know that young people can take very calm, cool, measured risks. Like this has been well established in the research lab. It's not that young people don't know how to drive a car carefully, because they can do that when they're by themselves, when they're alone. They're not crashing a car when they're alone. They're crashing a car and making silly decisions when their friends are there, because there's so much social reward that comes from taking a risk, because they're getting positive feedback from their friends, especially groups of guys, but girls do silly things too. So a lot of the sensation seeking and the risk taking is all wrapped up in the reward that comes from kind of the belonging and the tribe membership and the hierarchy and the status you might gain by doing the silly things. They're not doing that alone. They're perfectly able to make smart, cool, calm decisions. It's just when they've got their friends looking over their shoulder. And that's because reward and risk taking and sensation seeking is all mixed up with, tribe membership and social belonging and what can I do to fit in? And that's quite normal. Like that's healthy and normal. That's what teenage brains should be doing. Because we just really like to always just put a negative frame on that. We would never talk about toddlers learning to walk and talk. Oh, well, look at them on their legs. They keep falling over and they can't say words properly. Oh, well, once their brains are fully developed, I suppose they'll be able to speak more clearly and they'll be able to walk without falling over. We wouldn't say that to toddlers, but we are so dismissive to teenagers experiencing and making mistakes. We need to kind of, I think, reframe their brains as being at their peak, because they really are.
I'm thinking, oh, regret. Anyway, nevertheless, the next time when we experience massive changes of the brain would obviously be around pregnancy. Now, yes, this is when we have huge amounts of hormones surging. What are they doing to the brain?
Wow, very cool, very cool. So we get so there's lots of different hormones of pregnancy. There's masses of prolactin, which is the hormone that no one out there on social media is talking about. But, prolactin is like kind of the quintessential pregnancy hormone and has hundreds of different functions and roles throughout our body and brain. And that's produced both by our brain, but then massively by our placenta. When you've got baby inside and it's interacting both with the baby but also with you and your brain and your body and preparing you to carry the baby and then to be able to birth the baby and then to look after the baby afterwards. And then we've also got a lot of other hormones of pregnancy. So normally our ovaries and our brain are in quite a careful, thoughtful conversation and levels of estradiol are very kind of measured and well regulated, but that's all just like completely overridden by the presence of the placenta in the baby, so much so that we end up making a few different types of estrogen over the course of a pregnancy, so much so that the entire dose in a pregnancy of estrogen is 1,000 times more than the entire rest of your lifespan. So everyone's like kind of freaking out here and there about levels of ovulation, estrogen, and what's happening in perimenopause and menopause. But we just get this massive dose across the course of 9 months in one pregnancy, which I think is super interesting, because like kind of all of the brakes are off and all of the feedback loops have just been obliterated. So there's just like sky high levels of all of these different hormones, and these do have an impact on our brain. And the biggest change that we see in the brain outside of childhood and adolescent brain development is during the course of a woman's first pregnancy. And you end up, and I don't like to use the word lose, but if you were to look at the volume of the cortex, let me get my little brain. So the cortex is the wrinkly wrapping that we see on the outside of the brain. So in some parts of cortex, you'll get about a 4% volume loss, which doesn't sound like much, but even someone with schizophrenia, which would perhaps be one of the more serious psychiatric conditions, whereby we can get a pretty good gauge of what's happening in someone's brain, you're not going to see that kind of volume change. That's not to say that pregnancy is a psychiatric condition, but just to say it's a very unique neurological event. And most of the changes that we see are in those brain areas and networks involved with social cognition, basically our social brain, reading and responding to the social cues of other people, thinking what someone else is thinking, feeling, interpreting, and what would be the reason for that? I always think what's kind of the evolutionary mandate for the social brain changing during pregnancy? Well, it's really to prepare the mother's mind for motherhood once she's had the baby. Because what do we need to do to keep the baby alive? We need to pay a lot of attention to the baby and respond and react appropriately to that baby's cues. And as we're social creatures, we're social beings, and so it's us interpreting the babies, and then as our child gets older, their social cues to kind of mother them and to look after them and to respond to them and to want to respond to them. Because if we didn't want to respond to a crying baby, if we didn't want to, we can't, you remember when your babies are newborns and especially the second one, because you don't think about it with the first, the smell of their head, there's just, and you want to squish them because they're so cute. You just want to squeeze them really hard, but you're not going. And you just you are drawn to them. Even if they're crying, you just want to pick them up and comfort them, even though why would you want to pick up a crying human? Our brains are fundamentally drawn to care for that baby. Now, that doesn't mean every single woman who's gone through a pregnancy knows exactly how to, but it's a little bit like adolescence. Matrescence and adolescence is similar in that the brains become very plastic, and the experiences that we have with the baby kind of reinforce and reward a lot of those plastic changes, and I think perhaps make the learning curve a little less steep. So We've now got quite a lot of, we're starting to get more and more data, what brains look like before and after a first pregnancy. There's been some epic studies done of scientists put their hands up themselves, said, scan my brain every couple of weeks through the course of my pregnancy, and let's look at how my brain changes in response to the hormones. We've even got a little bit of a comparison between what happens if you have a labour and natural vaginal labour and delivery versus a cesarean. We haven't gone through labour at all. How long do these brain changes last? What happens in the, can we see the brains of women in their 80s? Can we tell if they've had a baby or not? And we can. There are traces of pregnancy and motherhood in the brains of women in their 80s and 90s. Wow. We can get a look at a brain biobank, and with about 80 to 90% accuracy, sort them into mother, non-mother, mother, mother, non-mother, simply by the structure and how their brains respond.
Yeah, I'll come back. Somebody asked an interesting question there, so I'm sort of breaking my logical flow, but I will come back to baby brains in a second. But I asked here, and this is an interesting question because actually I had dinner a few weeks back with 4 girls who I'd gone to school with, and I was actually early for a change. And they said, we're really, really surprised because you had a reputation of always being tardy. And I thought to myself, my God, of all of the things you could have labelled me with a reputation.
Oh, thanks for remembering that.
Yeah. So he's asking, because I'm thinking of all of the other things that I could have been labelled with then. And he's asking, are boys generally more reckless than girls, or are there differences between reckless behaviour, or are we?
Oh, yeah.
Yes.
I mean, there's two ways to look at this. So this is kind of going back to teenagers in particular. So we know that sensation-seeking, risk-taking kind of peaks at around age 16. And if we were to somehow quantify the risks that teenagers take, boys definitely take a whole lot more risks. And I have one of those. I have one who doesn't take as many, but then I also have a peak risk taker. Like, he's not the one that follows the others to jump off the cliff. He's the one that goes first and backflips off and films it. Like, I have one of them, and the studies say it peaks at age 16. He's 17 now. He's just got his P's, so hopefully we're kind of starting to come down off that. And when he's spending time with his girlfriend, they don't do as many silly things. They don't, go out and, boats at the middle of the night and water ski, whatever, all the kind of stuff they can do. So there are differences, but you could also say, do we perceive socially that driving in fast cars and swimming in the ocean at night and jumping off sea cliffs and drinking lots as risky behaviour? But perhaps, there's behaviours that, like having sexual relationship when you're 15, that's great if it's consensual and everyone's happy about it. But I mean, that's also quite a risky thing to do because you risk pregnancy, and that's perhaps one of the riskiest things we can do as a female. So there's kind of social ways in which we would measure risk and determine what's risky and what's not. But typically what we would think in Australia as being, risk-taking, sensation-seeking behaviour, males typically do that more. And partly that's about testosterone kind of driving that, because testosterone does drive that kind of masculine sort of seeking behaviour. But there's also a bit of that hierarchy kind of tribal kind of status in there as well, which girls might go about seeking in a different way, not so much by showing off, but maybe by perhaps trying to conform.
Yeah, like jumping.
But again, it's very hard because these are very broad generalizations, and it's hard not to make it sound like I'm saying stereotypes. But if we do quantify it, and we can look at like who gets the Darwin Awards for like doing a dumbass thing, it's typically me. I don't know whether any women have had a Darwin Award. Once kids get on their P's in Australia, and this is my house, provisional driver's license, and this is in my house like 3 days ago, like where that's like the peak of having a crash, like what are the males versus the females that are doing that? And it's typically the males. Girls still have crashes, but so it depends on how we quantify and what we measure as risky.
Yeah.
But yeah, boys do a bit more. God help. Like, oh my goodness, my like poor heart, my mind, it's very, very stressful. No wonder I drink too much wine, Fiona. The stories I can't share with you.
Later.
I can't write books about teenagers.
Well, not without really not look like that.
No, you have to write from a scar, not a wound.
Yeah, exactly. The pregnancy brain. Now, we've had this conversation before, and I think I remember telling you, my God, it must exist, Sarah, because I remember actually when I was working at the ABC, Australian Broadcasting Corporation, and I was literally 9 months pregnant. It was just about before I was going to go on maternity leave, and I'm sitting at my desk and I'm typing away, and the phone rings, and I pick it up, and the cameraman says, "Are you coming to this interview?" And I said, "What interview?" I had absolutely zero idea where I was supposed to be when. Yeah. I had to stop driving because it became dangerous. I was just vaguing out all over the place. So I would say yes, pregnancy brain.
Yes. So we've got pregnancy. And pregnancy is a very different physiological and neurological state to early motherhood, right? But when we say baby brain, we're conflating the two. So I don't know. I'm very much for having better definitions. I don't even like brain fog as a definition, but we can get to that. So 4 out of 5 women during pregnancy or in motherhood will put their hands up and go, yes, I experience moments like what you say. So the question is there some neurological deficit that we can measure and pick up? Is it real? Is it neurological, or is it due to sort of something else? And so if we look at pregnancy, the times in which in some women, in some studies, we can pick up tiny little perhaps reductions in their scores. They might normally score 30 out of 30 or 29 out of 30 on some kind of score of verbal memory or whatever. And typically it's verbal scores that we see changes in, similar to menopause as well. maybe they'll score 1 or 2 points less. Not all women, but some women in some studies, and it's the third trimester. And is that due to that massive reorganization that we see of social brain networks? Is the brain just kind of reorganizing itself? Is it to do with your attention? Because it's very hard to concentrate when you're 9 months pregnant as well. You've got you're constant, especially your first baby, you're constantly being distracted. So you're almost multitasking the whole time. Your attention is always shifting. So there's a lot of kinds of things going on there. And in motherhood, when we do, it's very, very rare to pick any kind of shifts in cognition up. And when we do longitudinal studies, which is what we ideally would do, we've got a massive group of women, we follow them the whole way through. Typically, we don't see any variation in test scores. And sometimes we see improvements in some types of cognition in women in the third trimester, particularly if it's like, remember this list of prices of baby strollers, like if it's a ecologically relevant memory test to a woman, then she will be more likely to remember that than someone who's not pregnant, which stands to reason, because you would be thinking more about the prices of strollers if you were pregnant and if you weren't. So then there's that dichotomy. Is there some neurological reason for these women experiencing this that we're not picking up? Or is there something else going on? And that people that have gone and interrogated that paradox have found, even the women who say, yes, I have terrible baby brain, and we're looking at motherhood, they are also more likely to be experiencing postnatal depression, be socially less supported, have poor overall well-being, not getting as much sleep. The women who are, and I had some women, I did lots of surveys for my baby brain book, and I had 2 women write in who are expats in Asia who had like live-in hired help, not just like a nice mum or sister or a useful husband. They literally had paid, home help. And they said, well, we didn't have baby brain. Motherhood was wonderful, because they kind of had a live-in paid village to kind of help. It was really interesting, their kinds of responses to a lot of this. So those women who...
That then is support plays a crucial role.
100%. And what we've got, especially in new motherhood, but also in the later stages of pregnancy, you've got a brain which has completely reorganized and rewired with the sole kind of evolutionary mandate. Mother Nature needs you to focus on your baby, not on when you had the meeting, did you buy new bananas, where's your husband's shoes, where's the kids, whatever's. All of the other things, like your attention has been completely shifted to focus in on the baby and nurture the baby, and you're almost kind of consumed with learning about this whole new human, but you're expected to do all of that plus all of the other things you did as equally well. And we've become more and more familiar with the idea of the emotional labor or cognitive load of motherhood. And if we think about cognition and we think about memory and we think about remembering to do things, well, that depends on attention, what information we take in and what we filter out. And it's not that the brain has become incapable of doing that, it's just the attention is completely consumed in one particular direction. And so it's not the brain that's letting us down, it's the world around us not supporting us to be able to only focus on that, but expecting everything else. And you know what they say, everyone loves a super mum. Let's get the super mum to do the job, because give a busy woman the job, she'll get it done, because it's okay if she fails or makes a mistake or whatever, because she'll just blame the brain anyway, because she's been told from puberty that female brains, when you add some hormones in and a reproductive transition, are dysfunctional and emotional and unstable. Of course, many women experience postnatal depression. That's not to deny any of that. But this cognitive instability is not a cognitive neurological issue. It's like a kind of an ecosystem. It's an ecosystem problem, because the very well-supported mums are less likely to report they were the ones with baby brain.
Now, interestingly, when we get to brain fog, the term which you said that you don't particularly like either, there have been some studies that show that women in workplaces who manage to suppress their symptoms do better, who basically sort of, plow on through. And there are some other ones that show that that support could also play a vital role there as well, that if your brain fog could be worse, you get to that sort of point where, we, as they say at the sandwich generation, we've got, aging parents in ill. We've got teenagers partaking in risky behaviour. We've got, pressures at work. We've got things being from all levels. How much of it then can we attribute to fluctuating insane hormones?
Yeah.
And vasomotor symptoms, and how much can we attribute to life, or do we just
that's the chicken and egg scenario, isn't it? And makes me think, because I know you've interviewed Pauline Mackey, who I think is a goddess, and I wish she would just do social media and just sort
it out.
Sort it out, Pauline, but I know she's busy, so we'll do it we'll be her kind of voice. So because that's her, Pauline Mackey, that's her kind of thing, is brain fog. I wish we could come up with better descriptions of things like baby brain and brain fog, because brain fog is used like if you've got ADHD, or if you've gone through long COVID, or if you've been treated for cancer, or if you've got glandular fever, or it's similar to the feeling like my brain isn't working and it's foggy and my memory isn't quite right, or I can't remember words or whatever, and we see similar sort of sets of symptoms in lots of different sort of life ages and stages and scenarios, and males and females as well. So sometimes I know it's a colloquial term that's really useful, but I think it would be more useful if we had better terminology, so we could separate out that menopausal brain fog from the other types of brain fog. But anyway, I think the issue is what's the chicken and egg scenario here? And a brain is I always I'm on the brains side, because we've got the hormone brain people and the heart brain people and the iPhone brain people and the sleep brain people, the social brain people, and the gut brain people. There's lots of messages and signals that the brain is interpreting and making meaning of from our body and from the outside world, and then filtering it through our expectations. Our mind is an incredibly powerful part of that mix. And so any kind of moment that you find yourself in, the brain is, receiving and making meaning of all of these signals. And then you're kind of, this is how I will think or feel or behave next. So, so there are different points in life when different signals are louder or stronger, or when we tune into different types of signals. So when it comes to brain fog at menopause, or perimenopause as well, is that a direct result of changing levels of hormones, or after menopause flatlining levels of hormones, or is it some secondary or tertiary consequence, or is it some intricate web? I'm in the intricate web kind of camp, because it's typically reported as part of a constellation of symptoms. It's more likely to be reported in women who have vasomotor symptoms and who also have lack of sleep, and perhaps are also struggling socioeconomically, or haven't had as, greater start in life, and haven't had as greater levels of education. It's often like a whole kind of constellation of symptoms there. But some women might just go through, have everything else is running just completely fine, and perhaps, and I'll put myself in this camp, you might just have a few verbal kind of weird things happen. So I have this really weird, and I'm 50, this really weird verbal switch whereby I do this kind of semantic switching, whereby one of the boys walked in the other day and he had a nice hat on. And I said, "Oh, that's a nice lid." I said, "I mean hat." And then I said to a friend, me and a friend were going out for breakfast the other day. It was about 7 a.m. I was staying at her place, and I said to her husband, "Oh, are you coming to the pub with us?" I mean cafe, not pub. And he said, "That's a bit early for that." So I'll do weird switches where it'll be semantically related. And do I think I have brain fog, or is that just a response to my brain going through perimenopause? So that's why I wish we had better terms for that. Is it caused directly by hormones? Let's get back to it. Rewind. We know that hormones cause vasomotor symptoms because the thermostat in the hypothalamus gets narrower, and that you get a tiny increase in body temperature and your brain goes into panic stations, and so you get sweats and you get hot, and then you try and cool down. And if that happens at night, and if it's happening during the day, it's happening at night, about 75% of the time you'll be woken up. You might not remember every single one of those awakenings, but regardless of how many times it wakes you up or not, it is disrupting your sleep. It's disrupting your sleep architecture, whether or not you're waking or not. And if you've got a few days, weeks, months, years of disrupted sleep, the inevitable consequences, your brain isn't going to perform as well as you would have liked. So is brain fog secondary to that? Is brain fog kind of hand in hand perhaps with mood disorders? So someone with depression, for example, clinical depression, brain fog might be a symptom of that. Is it partly to do with the direct impact of, and I think there's less of a case to be made for this, the direct impact of hormones perhaps on the functioning of neurons themselves in a cognitive sense, or is it more a direct consequence of ovarian hormones impacting the metabolic state of a neuron, whereby it's not able to kind of function energetically in the same way? So it's almost like it's a bit tired, would be one, like it's a bit fatigued. It fatigues easier. It doesn't take as much cognitive exertion for the brain to become fatigued, and that's perceived as brain fog. We don't know any of this. I'm just throwing different ideas out. Is it to do with, there's another idea, is it to do with, we see when you go through midlife, men as well, but particularly this is accelerated in women going through menopause, we see all of the brain networks that through puberty and adolescence get very segregated and refined and very good and flexible and efficient at their jobs. When you go through midlife, they start to become a bit more integrated. It's almost as if the brain is kind of, let's like cooperate a bit more, guys, to get the job done, because it needs to work that little bit harder, and the plasticity that it kind of displays is more brain cooperation and integration of networks instead of segregation. And is brain fog a consequence of the shift from segregation to integrated networks? There's a million different things going on here, and we don't know the answer. We do know that HRT doesn't necessarily always help, which is kind of a bit confusing and a bit, and I know Pauline Mackey has spoken to you about this. We've both written about it in our books. It's a bit of a mystery. It would be useful.
It is, but let's just unpack
if it did,
because we have a lot of obviously. The interesting thing out of this, if you go back to the pregnancy, you're looking at the 4% volume loss, and constantly being told that estrogen is exactly what the brain needs. We have all of this stuff from Lisa Mosconi as well that shows the change of energy being the ATP goes down. We have to
and that's what I was kind of talking about. And then it kind of recovers. So it may be that shift of, well, the brain is kind of going from the metabolic reproductive metabolic state, which is kind of energetic, and I can make a baby and I'm growing and building and shifting, to this post-reproductive state where it doesn't require the same energy. It's kind of going through that shift, and it could be that adjustment that feels foggy to some women, because we know typically like after they've gone through menopause, often women will say, I'm starting to feel better. And lots of women will go through this menopause phase. Some women will show no shift. They'll feel completely fine. Other women will say, I have brain fog, but we can't pick up any test score differences. And other women, we might say, actually your verbal, you're doing that semantic shifting, or you're doing, your verbal memory isn't quite as good. So other women, we will see a little bit of a shift. And then most of them will recover, not all, but most will recover. But is that to do with the metabolic? Is that to do with that metabolic kind of readjustment? It's likely it is. Yeah. And Lisa Mosconi's research does show, but we haven't got good longitudinal data. No. Lisa Mosconi's work is interesting, but it's looking at half of her subjects in those studies have the ApoE4 gene, which is a very strong risk factor for developing Alzheimer's disease. So it's not necessarily a normal, healthy population. It's not necessarily translatable to everyone. And she's been comparing a group of women who are premenopausal, a group who are peri, and a group who are post. What we need is the longitudinal study to follow that whole group through. Yeah. So, and then we're going to see different trajectories for different women, right? We're not going to see all menopausal women the same. We're going to see different types of women transversing through. And that's why it is so useful and important to recognize that there are this whole host of different experiences. It's a bit like PMS. It's a bit like, sometimes you have a great pregnancy, sometimes you're just like flatten your back for 9 months. Like what causes these differences? That's so interesting.
Yeah, exactly. And in her work, and actually, Mackay was actually the first person apparently to discover the estrogen receptors on the brain. And then now they've been picked up again by Lisa Mosconi, who's sort of showing that during this period, basically the brain is screaming out for estrogen, as we're told.
That's a nice analogy. Yeah, because what we see, and you see this in every system in the body, when there's a ligand and a receptor, whether it's a neurotransmitter or whether it's a hormone, and often you see this in the brain, when you get less of the ligand or less of the molecule, you get more receptors. So you get we call it receptor upregulation. You see this even at the level of a synapse. So if there's less of a ligand, often you'll get more receptors to kind of make the most of what is there. And I think I commented on one of her social media posts. I said, never is a receptor ligand, receptor upregulation study got so much global attention, because it's kind of what you expect to happen, because the brain will kind of upregulate, and then in time, if there's no extra estrogen added, then it will kind of down-regulate, and it's almost like the brain will wean off the need for estrogen, and then kind of carry on without it. But in that transition time, that doesn't mean some influences out there have. They've said
got to plug it with estrogen.
Yeah, they've said, well, the receptors are there. That means the brain wants more estrogen. Well, it's expecting it, and it's reacting and responding. Like, I'm pro HRT. Like, knock yourself out. Like, we don't have to. We can just have to. If you use it in a gel, you've got to put it on every day anyway. It's not like you're marrying it. It's not like a tattoo, where it's there for life. So just because the receptor's there doesn't mean we need to supply the molecule. Like, that's not necessarily what is happening, but that is how it has been interpreted. It's a little bit like saying, well, we've got cannabinoid receptors in our brain, therefore we must put lots of cannabis into that brain because the receptors are there.
Yes. Like smoking, when you give up smoking, and the receptors.
Yeah. So I mean, we're at very, very early stages in terms of understanding all of these shifts, and we've got brain fog, and then we've got lots of conversations around depression, and is what we're seeing in terms of mood. Vulnerability at this point in life is that, and this, and you talked about it, and I talked about it in my book, that great debate between Jureshri Kulkarni and Pauline Mackay is like, are these brand new episodes of depression, and women have never had it before, and therefore we should treat it with hormones, or is this recurring depression from women who have always been vulnerable, and therefore we should carry on with the same treatment they've been doing? And I think Pauline Mackay did a good debate there. But again, is it simply due to the loss of estrogen, or is it downstream of other impacts? Is it downstream of the thermoregulation that's disrupting the sleep? Is it downstream of the vasomotor? And my one idea that I'm really interested in exploring more, and there's very little research, there's some research being done in Santiago in Chile about this, is the idea that we've got autonomic sort of shifts in our autonomic system. So that's our sympathetic and our parasympathetic nervous system. And our sympathetic nervous system is just getting activated over and over and over again every time we have a hot flash, because that's how we vasodilate and sweat. And in particular, when we're asleep at night, we get a massive sympathetic surge, and we get release of adrenaline from our kidneys to wake us up, to behave, to cool ourselves down. You've got to be awake to do that. And we see in sleep apnea that the more sympathetic activation that you're getting over and over and over again, well, one, it's a cardiovascular stressor. If you're into things like heart rate variability, your heart rate variability is going down, and you've got more of a sympathy. You're more sympathetically activated than parasympathetic. You kind of lost that nice balance, and that all of that sympathetic activation. You feel wired but tired, and you feel more hypervigilant. And what happens is, when you've got that as a physiological response in your body, well, your mind sets in and goes, well, I'm feeling nervous or anxious or on edge. What am I going to worry about? And if you're 50, it doesn't take long to find something to worry about. There'll be 1,000 things, particularly at 3 a.m. Like if you're, and I liken it to anxiety, like the day if you drink a little bit too much, like I'm known to do, you sometimes wake up the next day and you're just like all tired and wired, and your nervous system's all dysregulated, and so then you start going, I must have done something terrible last night because I feel nervous and upset, and so then my brain is trying to fill in the gap, and that's, I think, what may be underlying. Lots of women start talking about how anxiety is being some of their first symptoms, but we're not really thinking. We're so busy focusing on the brain, we're not thinking about the nervous system, we're not thinking about autonomic nervous system regulation, and that's all tied up with cardiovascular health as well. So that's why I said there's this complex web in there that we need
vulnerable brain
trying to unwrap and unravel and understand. And if we understand that, we see the same after pregnancy. When you, especially after your first pregnancy, after labor and delivery, you're very, very hypervigilant. You're very, very massively sympathetically activated. You've lost all the estrogen from pregnancy, and you're very, very, like, your heart rate variability will be really low. You might be getting lots of heart palpitations. You've just brought home this new baby. You're on edge, and you get all of these catastrophic, intrusive thoughts about, you're like, what's going to happen? Something terrible is about to happen. So, of course, your brain starts imagining something terrible happening to your baby. It'll fall out the window or down the stairs or out of the car, or you'll drop it on the tiles. And so your brain will start to fill in the gaps. And I think that we think that our brain is making all of this up, when what is happening is our mind is filling in the gaps when our autonomic nervous system is kind of become a bit out of whack, which may be a downstream consequence of the hormone shifts.
Yeah. Now, the interesting thing about that, just going back to the estrogen for a minute, is that, with the argument about, giving the receptors the estrogen that they need, the one that comes along with that is, of course, that estrogen is going to prevent dementia and all of those sorts of
Yeah.
At the moment, the studies are either at best neutral, or some of them even negative. So we're not sort of where we really should be on subject that we should be preventer. But you talk about it in your book, the things that we do know that can help up to 45% or so cases. What should we be doing for our brain?
Yeah. So I always think about, like, dementia risk. We've got, risks, things we can, that are going to kind of tip the scales away from us and towards us in our favor. I always imagine those old-fashioned scales. And I think we should say, in terms of HRT and cognition and dementia risk, for women who are going through menopause at, say, like age 50, 51 or whatever, that is a different risk profile than a woman who's got premature ovarian insufficiency. She hasn't had a period after the age of 40, or maybe even in your early 40s. There appears to be a different risk profile there. And so there's a bit, and we're not entirely sure why that is. But certainly, if we are to look at, like, risk for dementia and the things that we know protect and the things that we know harm, there's some things we know are protective and some things that we know are harming. And at the moment, the studies for HRT, we're kind of putting a little weight on either side. We don't know how big and heavy the weight is. And so each study that comes out, we're kind of putting a weight on either side. So we're kind of, and that's so interesting to me, because maybe exogenous estrogen isn't like the key that's going to tip the scale heavily one way or heavily the other. I think it might end up being kind of neutral, and maybe post-reproductively, brain, like, there's lots of benefits and upsides for continuing to give yourself some estrogen, help your vasomotor symptoms, keep your bones strong, all of the other, things that may or may, we've got different levels of evidence for them. Maybe it is that brains aren't going to go down that dementia path, or not, based on that exogenous estrogen or not. It may be that our brains have evolved to age without it. Doesn't mean we can't take it, but maybe they will. And maybe what happens is a brain will wean off estrogen, and then we put it back in down the track. And this is certainly this idea of this window of opportunity, that then a brain that's kind of weaned off estrogen, we kind of has started to reorganize, and putting it back in causes more damage than benefit. And that's why where some of the risk studies come from. We don't know whether women taking HRT are taking it because they're the ones that have got more cardiovascular vulnerability, because they're the ones with the hot flashes, and actually they're the ones that are going to see more benefit than women who aren't having hot flashes and are just taking it anyway. So that's why the scales are, some studies are on this side and some studies are on that side. In terms of what we do know, so if we look, and so the latest study that's come out, that they do this every few years, it's published in the Lancet, and it's the Alzheimer's, don't quote me on exactly what it is. Have you got it in front of you? The Alzheimer's Association
No, it is normally studied
study that, yeah, it comes out in the Lancet every few years, and they look at all of the risk factors globally, and this is looking at everyone across the whole world, not just wealthy white social media influencers like ourselves, Fiona, but you know, what are we and influencers.
I think actually the only one that
we're
really
very
white.
Let's just go with white. Middle-aged white ladies. Listen to them. So let's look at everyone in the whole world, not just us. What do we know is going to help and what's going to harm? And so we've got modifiable risk factors, so things where we can actually shift, and then we've got unmodifiable. So about half, 55% of things you can't do anything about. You can't do anything about getting older. You can't really do anything about your genes. You can't go and switch the genes around that you've got, your genes that you've got. And then we've also got what we might think of as biological sex factors, whereby particularly once you get much, much, much older, there is a slightly increased incidence, which is more women getting diagnosed with Alzheimer's disease than men, but overall the prevalence pool, there's more women floating around it than men, because the men die off a bit younger and the women tend to live a bit longer. So there's a combination of longevity in there, but also other factors which come about via what we might call these gendered factors, so experiences that you had through your life, pregnancy, reproductive hormones, etc. So if we look at the modifiable factors, and lots of people have moaned and groaned that they didn't look at HRT, they didn't look at menopause. They did, but because the scale, they didn't know what the scales have got weights on both sides, they couldn't add it in, right? Because they had to say it's a bit like this. So we've got education, particularly, and this is talking about education in childhood and adolescence. And we know if someone's, had, you compare someone who left school at 12 versus someone who left, went right through and started a PhD and left in their late 20s. So the more years of enrichment and intellectual cognitive stimulation you've got, the more resilience you will have to Alzheimer's disease and later in life. That's about 5% of cases perhaps could be prevented by ensuring that more people stay in education for longer. And that's particularly relevant for low middle income countries, and particularly girls who may not be getting the same access to education as boys. And we know that that's certainly the case even now in parts of the world, not just people in their 80s now looking back to what life was like for them in the 1930s or 40s. In midlife, we've got a kind of a cluster of we would call like cardiometabolic factors. So we've got things like having, healthy cardiovascular system, low blood pressure, looking at, your LDL cholesterol levels, looking at things like type 1, type 2 diabetes. Don't necessarily almost do as much about type 1 as type 2. Overweight and obesity, a lot of those kind of cardiometabolic factors are in there. And we've also got some factors like air pollution, which not everyone can do anything about individually.
Yep.
But, that is a modifiable factor if anyone cared to do anything about it. And then this massive chunky 7% factor, which I think is totally fascinating. And this, as I always say, is deeply unsexy. And so the menopause influencers aren't talking about it, is hearing loss, particularly untreated hearing loss at midlife. So that's really a significant chunk of Alzheimer's disease could be prevented globally by treating hearing loss at midlife.
Yeah, and it's a difficult one, isn't it? Because nobody wants to be a hearing aid at the age of 50. But I think
but hearing aids are getting much smaller than they used to. Like they used to be really obvious, and there was a lot of stigma. Whereas now they're pretty much invisible. And people can have them just on their glasses, and you've got your little mobile phone to like dial in and dial out. So I think, and that's like things like industrial related hearing loss. There's lots of factors that go towards that. And is that because losing your hearing in some way harms your brain, and we don't know whether it's obviously when you can't hear, you've lost a massive degree of that outside in stimulation and sensory input that's coming into a brain for a brain to make meaning of the world, and also because you become very socially isolated and you're cutting yourself off from a lot of things. So that social factor is kind of secondary to that. But then if we look at the later life risk factors, social isolation per se is another modifiable risk factor, as is vision loss in late life. And off the top of my head, there's a couple of others, things like depression. Alcohol sadly made its way in there. I think it was about kind of 1 or 2%. And I say sadly, don't drink too much alcohol, people. And depression. And a lot of these, it's not necessarily, and head injuries like concussion, like don't climb ladders and clean out the gutters once, you pass midlife, get the young ones to do that. So there's all of these factors in there, and I feel like within the menopause space, the only thing we're talking about is HRT, and I think right now that there's the evidence for that is nowhere near as clear as it is for everything else. And also with HRT, which I think is a cool and useful tool, it's like a blunt tool, because all we can just keep adding more in. Just increase the dose. You're not like titrating it daily like your brain and ovaries do, alongside other kind of. We're not doing that, right? Which maybe that's what a brain needs. Maybe the brain needs that subtle, careful, thoughtful conversation, not just here's some estrogen, brain, and just stuff more in and hope for the best.
Yes, I don't know. There is a whole thing that's starting now about cycling your HRT, and these things just do my brain in, really.
Yeah. But I mean, maybe that's what our brains. Maybe we just need.
True. I think in the future they've got people who are looking now at developing the things like the the one for the blood sugar measuring, where you could have where it could deliver a slow dose or release as things flow. I mean, things will change.
Yeah.
I guess in the
future. They will, but I'm not. And what's really interesting is if you look at, like, say, the UK Biobank data and look at like Alzheimer's risk and also look at cognitive test scores, there's a way stronger signal for the oral contraceptive pill. And no one's banging on. Everyone's like thinking that that's like you might as well have snorted cocaine every day of your life. And, if you listen to some kind of stories about how harmful a pill is, but actually the cognitive benefits and Alzheimer's disease risk reduction that comes about from long-term oral contraceptive pill use is actually a much stronger signal than HRT. And that's fascinating. And is that because of all of the estrogen, the synthetic estrogen that everyone's like poo-pooing, which is actually really great if you don't want to have a baby, right? It's great to have, fertility choice, right, and reproductive decision-making. Or is it to do with the androgenicity of some of the types of synthetic progestins? I always get muddled up between progestogens and progestins that are in the pill, whereby some of them act a little bit more like an androgen, and that may be more neuroprotective and improve cognition in some women than others. And no one's talking about that.
Yeah, I think there's a lot to be done there.
Yeah, everyone's just kind of, don't take the pill, but you must take HRT, when actually the data's kind of the other way around when it talks about dementia risk. So this is why it's so useful to look at women's health across the lifespan and look at all the data. And what's really cool, I'm just babbling away at you here. I just think all of the data that is starting to emerge, we've got biobanks, we've got data sharing, we've got machine learning and AI that enables us to analyze, hundreds of thousands of brain scans that have got hundreds of thousands of measures each. We're going to start getting there soon because the data is going to give us the answer. And that's pretty cool and exciting. And it might not be the answer that we want to hear. It might not be the answer that that everyone's going to make money for people. Who knows?
Who knows? But
Like
even
the menopause industrial complex.
Yes, it is.
Who knows what the data is going to do to support that or annihilate it?
I don't. Well, they don't seem to pay any attention to that, do they? And speaking of babbling away, we have gone for 1 hour and 18 minutes, so I think we should probably call it quits there.
I'm very long-winded.
Where do people find the book? Should they wish to find it, because they definitely will read it.
It's a little. We have a few issues. So on the global access on sort of Spotify or Audible audiobook, not read by me because Audible doesn't like my voice very much, but that's okay. I have a wonderful narrator, Fiona McLeod, who narrates my books. That's, no matter where you are in the world, you'll be able to get a copy of that. Different parts of the world have got different access to the updated ebook because just rights. You can ship a copy from Australia, and all the Aussies and Kiwis will be able to get it on the bookshelves. And if you're desperate and you really can't find a copy anywhere, email me and I will try and help you out.
Brilliant. All right. And is there an email that they can email you on?
Just go to my website, drsarahmckay.com, and fill in the contact form and get in touch.
Brilliant. Excellent.
And then I've told them everything anyway. I've given my,
my
1 hour and 18-minute lecture.
There is way more in that. So I shall end this over here on the Instagram. See you there later on. I will end that, and I will end this here. And thank you so much again. Take care.
Bye.